Hello, good morning everyone. Today we will discuss second chapter of your book, Polynomial. Polynomial. Basically, what is the mean by a polynomial? So, as you read in class 9 also, polynomial is an algebraic expression, especially in one variable. It is a special type of algebraic expression which have only one variable. In class 9th and class 10th, we are dealing in polynomial of one variable. So basically, polynomial is an algebraic expression in which the power of each and every variable would be a whole number. Getting? I'm repeating my word. The power of each and every variable would be a whole number. For example, if we are writing like this, px is equals to 5x raised to the power 5 plus 3x square minus 2. So in this, we can observe we have a single variable because we are writing here px, polynomial of variable x. It would be pm also if we are using variable m. So we can write another polynomial like 6m square minus 2m minus 6. So in this polynomial, you have a variable m. Basically, polynomial is a single variable algebraic expression in which the power of each and every variable would be a whole number. Likewise, the power is 2, it is a whole number. The power is 1, it is a whole number. And here, x raised to the power 0 and 0 is also a whole number. So yes, it is a polynomial. Get it? Similarly, here in this we have 5x raised to the power 5 plus 3x square minus 2. In this, 5 is a whole number, 2 is a whole number, and similarly x raised to the power is also a whole number. So this is a polynomial which you have already read in class 9. So now after that, what you read about the polynomial? You read about the polynomial coefficient. So what is the mean by a coefficient? What is the mean by a coefficient? Basically the number multiplied with the corresponding variable. Just focus on the word. I said the number or constant multiplied with the corresponding variables. Because if I am talking about this particular polynomial, we have different variable in terms of x. We have x squared, we have x raised to the power 5, right? So now in this we have x raised to the power 5. So if we need to find the coefficient of x raised to the power 5, so I told you the number or constant multiplied with the corresponding variable. So here coefficient of x raised to the power 5 is equals to 5, and the coefficient of x squared would be 3 because 3 is multiplied with x squared and here 5 is multiplied with x raised to the power 5. Similarly, if I am talking about this particular polynomial, here for this coefficient of m squared, this is m squared, this is m, right? So what is the coefficient? Because 6 is multiplied with m squared, so 6 is the coefficient of m squared. If I am talking about this coefficient of m, so clearly we can observe minus 2 is multiplied with m, so the coefficient is minus 2. All these you have already read in class 9th. After that, you have discussed already in class 9th degree. So what is the mean by degree? The maximum power of variable. So again I am taking these two polynomial, and here you can observe we have a single variable m because we are dealing in a one variable polynomial. So here m is the variable and the maximum power is 2. So its degree is 2 because the degree, what is degree? Maximum power of variable. because m square, m and m raised to the power 0. So here m raised to the power 2 is the highest power. So this is the degree of polynomial. So similarly here we have the maximum power of x is 5. So here degree is 5. So according to degree we can classify the polynomial. If degree is 1, then this is known as linear polynomial. And what is the standard form? The standard form is ax plus b. If degree is 2, then this is quadratic polynomial. And what is the standard form? ax squared bx plus c. Similarly, if degree is 3, then this is cubic polynomial. And the standard form is ax cube bx squared cx plus d. Similarly, different. If the degree is 4, then this is biquadratic. And similarly, the standard form would be ax raised to the power 4 bx cube cx squared and d, where a, b, c and d and dot dash all are the real number, or we can say that these are the constant values. Getting? All these are the division of class 9th, and according to degrees in this class we have discussed about the geometrical representation of polynomial. Means how can we draw the graph of the different polynomial in case of linear, in case of quadratic, in case of cubic or biquadratic. Just a moment. Likewise, if I am talking about graphical representation of polynomial. If we're talking about first one, this is linear polynomial. As we know, this particular word linear means a straight line. Right? This word is related to science. Right? Getting? So straight line means if we draw a graph of a linear polynomial, it always would be a straight line. Likewise, we have a polynomial px is equals to 2x plus 5. And we need to draw the graph of this particular polynomial. So for this polynomial would be taken as y is equals to this, because to need or to draw a graph we need two variables x and y. Because of these two variables we can find out the coordinates, as well as we are able to draw the graph. So now px is to be taken as y, so y is equals to 2x plus 5. So when we are finding the two coordinates by putting different values of x, we are getting different values of y. So if we draw x is equals to 0, then we are getting y is equals to 5, because 2 multiplied by 0 is 0, then 5 is left. And if we take x equals to like minus 2, then it would be 2 into minus 2, minus 4 plus 5, that means we are getting 1. So we have the two coordinates 0, 5 and minus 2, 1. And if we draw the graph of these, the graph would be like this. As you know, this is your x-axis, horizontal axis. This is your vertical axis, y-axis. As we know, this is the origin. On the right side, they are the positive values. On left side, all these are the negative values. upside are the positive values, downside is the negative values. Getting? So first we need to plot the points, and after plot the points, we will join these 2 points, and we are getting the graph of linear polynomial. So the first point is 0, 5. So where is x is 0? At origin the x is 0 and y 5. So we need to move upwards because y is positive. So 1, 2, 3, 4, 5. So this is your first point, 0, 5. Right? Now we will plot the second point, which is -2, 1. So x -2, that means left side from the origin, 1 to -2, and y is positive, that means we need to move upwards. So here y is 1 is here and x -2 is here, so this is the point. Right? Now you have the 2 points on your Cartesian plane, so if you join these 2 points, you will get a straight line for px is equals to 2x plus 5. And you can observe this graph intersect x-axis at one point. Right? So this is the zeros. Simply, when you draw the graph, if your polynomial in variable x, so if you draw the graph or curve on a Cartesian plane, you have to check the curve or line cut the x-axis how many places. These are the number of zeros. Likewise, because it is a straight line and x is also a straight line, and two straight lines can be cut or intersect each other at one point, so linear polynomial has 1 zeros. Reason? Number of degree is equals to number of zeros, because we have degree 1 in linear, so that's why we are having a 0, 1. You can observe the line cut x-axis at the one place. Right? Second thing, graph for the quadratic polynomial. Suppose we have a polynomial px is equals to 2x squared minus x plus 5. So we can take px as y. So now we will find some points by putting different values of x and y. To draw the graph of a quadratic polynomial, we need to find more than 4 points to draw the curve or graph. If we are putting x equals to 0, then what we are getting? Only 5. Right? Because 2 multiplied by 0 is 0, minus 0, 0 minus 0 is 0, then what is left? 5. If we are putting x equals to minus 2, so if we are solving this here, so it would be 2 into minus 2 squared minus 2 plus 5. Then what we are getting? 2 minus 2 squared, 4 minus minus plus 4 plus 5. 4 2s are 8 plus 4 plus 5. 8 plus 4, 12 plus 5, 17. So we are getting 17 here. Right? Again, if we are putting different point, likewise 3 here. So now check what we will get. So now we just change these points. It would be square of 3. 3 squared would be 9. It would be minus 3. So 9 2s are 18. Minus 3 plus 5. So it would be 18 plus 5. 23 minus 3 is equals to 20. So this time we are getting a point 20 here. We need to find some more points. Likewise, minus 5. So again we are putting x equals to minus 5 here. It would be minus 5. Square of minus 5, 25, and it will be plus 5, and again 25 2s are, it is 50. what we are applying? We are applying board mass. First we have to multiply, then we have addition. Then 5 plus 5, 10. So it would be 60 here. So 60. Right? Similarly, if you just find out the different points, and if you plot these points, you will get a curve. Likewise, suppose now this time these points are too bigger, 5, 17, 20, 60 on y-axis. So how can we plot these points? So we can take a scale on y-axis पर हम एक स्केल चूज कर सकते हैं. 1 unit is equals to what? 10. Right? So this is your 10, 20, 30, 40, 50 and 60. And similarly, because these are the small points, so on x-axis we can choose a scale. 1 unit is equals to 1. So it would be 1, 2, 3, 4, 5, 6, 7. X dash, y or y dash. Right? Similarly, -1, -2, -3, -4, -5, -6, -7. And again, y negative, -1, -2, because we don't have a negative sign in y. So now we will plot the points. The first point is 0, 5. Where is 0, 5? 0, 5. This is your first point. Right? The second point is -2, 17. -2 and 17 is here, somewhere in between 0 and 20. This is 3, 20. 1, 2, 3 and 20. This is 20. And this is -5, 16. -5. 1, 2, 3, 4, 5. And this is 60. So it will be here 60. Similarly, if you draw another point, it would be somewhere like this. Here. Now, if you join them, you will get a curve like this. Right? So this curve is known as parabola. Right? This is Newton's. This is Newton's for you all. Parabola. So parabola would be open upward or would be open downwards. Right? So in what condition it would be looking open upwards or open downwards? So it depends on the value of what is the standard form of a quadratic polynomial. This is ax square bx plus c. So if a is greater than 0, then parabola would be open upward, and if a is less than 0, then the parabola would be open downwards. Right? So if according to graph you need to find the number of zeros, so in this graph we can observing the curve is not intersect x-axis. I'm repeating my word. The curve is not intersect x-axis. Clearly observe, because your polynomial in variable x, so we have to check the curve intersect the x-axis on how many places. So here the curve is not intersect the x-axis. So according to graph we can see that no zeros. Right? Sometimes in parabola you get a curve like this. So clearly we can observe the curve intersect x-axis at two places. So you can write here you have two different zeros. Sometimes you have a curve like this. The curve touches the x-axis at one point, so you can write here 1, 0. Right? Sometimes you get a curve like this. In this case, the curve is not touching the x-axis, So you also said because it not intersect x-axis or not meet x-axis. So in this case, no zeros. Similarly, if you draw the graph for a cubic polynomial, it would be somewhere like this. The curve intersects x-axis at 3 different places. Similarly, in biquadratic, the curve intersect x-axis at 4 places. With the help of these, you can do your exercise 2.1 easily. Now, we will move to the next exercise 2.2. Just a moment. Make sure all of you just note down all the contents which I have explained you. The next is relationship between zeros and coefficients. Right? First I am talking about a quadratic polynomial. We have a quadratic polynomial. So first we are taking the standard form of a quadratic polynomial. So what is the standard form of a quadratic polynomial? Px is equals to ax squared bx plus c. And what is a, b and c? These are the coefficients. What? Of x squared, and this is the coefficient of x, and this is the constant value, right? So how can we relate zeros to the coefficient? So first we must know what is the zeros. So zeros what? This is the value of variable at which polynomial becomes zero. Means in simply or in Hindi हमें x की एक ऐसी वैल्यू लेनी है, right, जिससे हमारी polynomial क्या बन जाए? Zero. For example, suppose px is 2x plus 5, right? In class 9 you find the zeros of this kind of polynomial. How? You have put this polynomial is equals to 0, then you are getting the value of x minus 5 by 2, right? In class 9 you said x is equals to minus 5 by 2 is the zero of the polynomial, right? Now we can check it. How? We are just putting this value in this polynomial, and if the answer becomes 0, then yes, x is equals to minus 5 by 2 is the zero of this polynomial. So if we are putting the value of x minus 5 by 2 here, then what we are getting? 2 ones are 2, it would be minus 5 plus 5, it becomes 0. So we can observe at x equals to minus 5 by 2, my polynomial becomes 0. So this is the zeros of the polynomial. Getting? So because in this we have numbers, so the value of x would be in the numbers or in fractions or in rational numbers. Doesn't matter, because now we need to relate zeros and coefficients. So for this we are taking let alpha and beta are the zeros of px, means polynomial. It means x is equals to alpha and x is equals to beta, right? Alpha and beta is nothing these are the symbol to represent the different values of x. Simple. So if x equals to alpha and x equals to beta are the zeros, so simply we can say that x minus alpha and x minus beta, what are the factor of px? Simply x is equals to alpha and x equals to beta, if the zeros, then we can see that x minus alpha and x minus beta are the factors. Get it? Sure. So now in class 6 you read a simple definition. If a number is divisible by two composite numbers, then it is also divisible by their products. Getting? So these are the two composite numbers. If we say these are the zeros or factor, means factor is a number by which a number is completely divisible. First I said ki x minus alpha is a factor, and then second side I said ki x minus beta is a factor. That means a number which is divisible by this and this individually. So it is also divisible by their products. So we will find the product of these two. So what we are getting, it would be x squared minus alpha plus beta x plus alpha beta, right? Because we have taken alpha and beta from our side, so we are using a constant value here, k, right? So when we multiply this k in this bracket, so what we are getting kx squared minus alpha plus beta x minus k into alpha plus beta x plus k alpha beta, right? So this is your first polynomial and this is your second polynomial, and if we compare them, what we are getting, what is the mean by comparing? We are comparing the coefficients of the different or the same variables. So in this x squared, and what is the coefficient of x squared? Here is a and here is k. So simply we can say here k is equals to a. In this we have the coefficient of x is b, and here we have the coefficient of x is minus k into alpha plus beta. So b is equals to minus k alpha plus beta. Similarly here constant value, if we are comparing the constant value, so here is the constant value c and here is k alpha beta. So c is equals to k alpha beta. So if we opt these part, so minus k alpha plus beta is equals to what? B. Then alpha plus beta is equals to minus b upon k, and we have the value of k which is a. So alpha plus beta is equals to minus b upon a. This is the relation, means the sum of zeros is equals to minus b upon a. Similarly, if we have taken this part, then we are getting alpha plus b, alpha beta is equals to c upon k, means alpha beta is equals to c upon a. This is the another relation in between zeros and coefficient. Alpha beta means product of zeros is equals to c upon a, and here sum of zeros is equals to minus b upon a, right? So this is the explanation how can we relate zeros and coefficients. Everyone note it down. First of all, you can pause the videos and note all these things. Afterwards, I go through the question number 1 of your second exercise 2.2. Just a moment. Okay, in exercise 2.2, in question number 1, first part, he said the statement is find the zeros of the following quadratic polynomial and verify the relationship in between the zeros and the coefficients. So the first polynomial is x square minus 2x minus 8. So as we know, this is a quadratic polynomial, and how can we solve it? How can we factorize? By using middle term splitting method. How can we solve it? We are multiplying the coefficient of x square to the constant value. So what is the coefficient of x square? This is 1. And what is the constant value? Minus 8. So we are getting minus 8 because we are getting a negative value. So we need to find the difference of two numbers, which is equals to 2, not minus 2. Just leave this symbol. The difference of two numbers would be 2 and their product would be 8. So the numbers are 4 and 2. Means if we subtract 4 minus 2, then we are getting 2, and if we multiply these two, 4 2s are 8. X minus 8. So x square minus 4x and minus minus plus 2x, and it would be minus 8. What is this? What is the common in these two? X. So it would be x minus 4, then plus 2 is common, x minus 4. So x minus 4 is your first factor, and the second is x plus 2. Then 4 zeros. What we did? We are putting the different both means factor is equals to 0 separately. So first factor is x minus 4 is equals to 0, then we are getting x is equals to 4. Second is x plus 2 is equals to 0, then we are getting x equals to minus 2. So this one, now you are here you are having the different values of x, which we have taken alpha and beta. So first you have taken as alpha, the second you have taken as beta. Now we need to verify. What does that mean by verify? Verify means you have to show LHS is equals to RHS, right? So now the first is sum of zeros, means alpha plus beta, which is equals to minus b upon a. From where we are finding the value of a and b and c. So you have to compare your given polynomial to the standard form. So what is alpha? 4. And what is beta? Minus 2 is equals to minus. What is the value of b here? This is minus 2. So minus 2. And what is the value of a? This is 1. So 4 plus minus minus is equals to minus minus plus 2. So because it is positive, we don't need to write a positive sign. Then 4 minus 2 is 2, and this is 2. So here LHS is equals to RHS. So this is verified. Similarly, you have to check the second C upon A. What is alpha? 4. What is beta? Minus 2. And here, what is the value of C? Minus 8. So it would be minus 8 upon 1. So 4 2s are minus 8. Minus 8 upon 1 is minus 8. Again, LHS is equals to RHS. It is also verified. Right? Getting? So everyone, note it down here by pausing the videos. Okay, now I'm just go through the second question of your book. Now, question number 1, question number 2, question number 3, all are same, as well as question number 6. So means 1, 2, 3 and 6 all are same questions, and question number 4 and question number 5 both are same questions. So I am doing fourth part of question number 1, which is 4u squared plus 8u. So in this we don't have a constant value, right? So it is very difficult to solve by using middle term splitting method. So we are solving in a different method. So what is common in these two? We can observe 4u is common. Then what is left? U plus 2. Means my polynomial pu is to be converted in these two factors, 4u and u plus 2. So 4 zeros, 4u is equals to 0, that means u is equals to 0 upon 4, it means 0. And same, u plus 2 is equals to 0, that means u is equals to minus 2. So here you have different values of u. U is equals to 0 and u is equals to minus 2. So one is to be taken as alpha and the second is to be taken as beta. You can take alpha and beta anyone according to your easiness. So now it's time to verify alpha and beta, which is equals to minus b upon a. Now just check it. In this you have a variable u. So in standard form you just change your variable according to question, because in this question we have a variable u. So you can write your standard form like this: au square plus bu plus c. So if we are comparing them, means given polynomial with the standard form, then we are getting the value of a, b and c. So now putting the value of alpha and beta, we have alpha 0 and we have beta minus 2, right? And if we are comparing, we are getting the different values of what? B and A. So here the value of B is 8 and the value of A is 4. So 0 plus minus 2, it would be minus 2, and 8 divided by 4, it would be minus 2. So it would be LHS is equals to RHS. So it is verified, right? Similarly, alpha beta, which is equals to C upon A. What is alpha? 0. What is beta? Minus 2. What is the constant value in this polynomial? 0 upon 4. So it would be 0 is equals to 0. So again LHS is equals to RHS. It is also verified. Now in question number 5, this is t squared minus 15. It is somewhere different or typical, because in this type question some of the students are facing problems. How can we solve it? In what way we can solve this? So clearly we can observe here t square is a perfect square number, and as we know 15 is not a perfect square number, but we can convert this polynomial like in this form: t square and minus under root 15 whole square, because under root 15 whole square would be equals to 15, means we are just changing in the question is a small change. Under root 5 under root 15 square is equals to simple 15. So now pt would be t square minus under root 15 whole square. So clearly we can observe a square minus b square, which is equals to a plus b or a minus b. So this particular polynomial can be written as under root t plus under root 15 or t minus under root 15. Now after that you got two factors, t is equals to this and t plus under root 15 is equals to 0. Then you are getting t is equals to minus under root 15, and if you are putting this is equals to 0, then you are getting t is equals to plus under root 15. Means you are getting alpha and beta, and afterwards you go through in this way. Getting? So with the help of these solutions, you can easily solve first question of your exercise 2.2. Right? Everyone note it down and complete your question number 1. Okay? Now I am solving the next question of question number 2. So first we read the question. The question is, find a quadratic polynomial each with the given number as the sum and the product of its zeros respectively. So in this, likewise in question number 2, first part, 1 upon 4 comma minus 1. He said sum, that means the first is sum of zeros and the second is product of zeros, right? So the simple formula, form of quadratic polynomial means this is k x squared minus sx plus p. It is nothing, means it's not a typical. Recently I have told you, or when we are taking x is equals to alpha and x is equals to beta, then this particular step we have already written in this form. Means on the place of alpha plus beta I am using s because these are the sum of the zeros, and on the place of alpha beta I am using p. This means this is the product of zeros. Now you can put the values of this. So here alpha plus beta is equals to 1 upon 4 and alpha into beta is equals to minus 1, and if we are putting, that means this is s and this is p. So now put these values here. So k x square minus, what is the alpha plus beta? 1 upon 4 x plus, what is alpha beta? Minus 1, right? So it would be k x squared minus x by 4 minus 1. So this is not your answer. First you have to take the LCM. So take the LCM. What is the LCM? This is 4. So it would be 4x squared minus x minus 4. 4 is to be taken outside. So k upon 4, 4x squared minus x minus 4 is your answer. In your NCERT book, this answer is to be given because this is constant value we have taken from our side, so this would be hidden. So this is your answer, 4x squared minus x minus 4, right? Now with the help of this particular formula you can solve all the part of question number 2, right? Now I am solving one more part, which is second part. The second part is under root 2 or 1 upon 3. So here, what is this? This is S and this is P. Means these are alpha plus beta, which is represented by S under root 2, and P means alpha beta, which is 1 upon 3. So form of quadratic polynomial, what? K x squared minus sx plus p, right? Now put the values. It would be k x squared minus, what is s? The s is under root 2 x plus, what is p? 1 upon 3. Again just check this step and this step, these are the same. Now what we are taking? LCM. By taking LCM, what is the LCM? This is 3, so it would be 3x squared minus 3 under root 2x plus 1, right? 3 is taken outside, so it would be k upon 3, 3x squared minus 3 under root 2x plus 1 is your answer, right? So with the help of this formula you can easily form a quadratic polynomial. Get it? When we are solving 2.4, then I told you how can you find a form of a cubic polynomial. Okay, now we can move to the next exercise, 2.3. I think this is sufficient material for today. You can easily solve 2.1 and 2.2 completely, and afterwards you can I'm sending you second video, means in which we will solve 2.3. थैंक यू फॉर टुडे।
भाई यार अमरप्रीत, यार तो ये अच्छी बात नहीं है, तो यार बंद हो गई बीच में तो।